record. So this is 2019 60 past paper. The duration is hour 15 minutes. You have 60 questions which are required to complete within that time. First question is, item 1 refers to the following diagram of a regular hexagon, A, B, C, D, E, and F. In the figure above, A, B, C, D, E, and F is a regular hexagon. What is the angle of X? Answer is 60. Answer is 60. So this is the correct answer, 60. On to question number 2. The diagram illustrates the proper method of, this is basically an ellipse, and here we have the focal points. We have the focal point 1 here, focal point 2. We did this in class, right? Yeah. We have the normal and the tangent. This is the normal and the tangent. To solve this, we must find the focal points first. To find the focal points, well, let me go through the answers first, or probably I should explain first. To find the focal point, you open your compass to half the major axis. Half the major, to see here half, or you can half the major axis. Then you place it here, which they did, and they describe an arc. At the point where the arc meets the circle, those are the focal points. To get the tangent, you need to identify a point. Say here is my point. Their point is here. I choose to make here be my point. The next step would be to join F1 and F2 to that point and bisect the angle that is formed here. And the bisector is the normal, as you see here, is the normal. Now, to get the tangent, you simply construct a perpendicular line to the normal by using the regular construction process. Yeah, so let's check out the answers. The diagram, well, construct, so this the answer here is, let me see, A says constructing an ellipse with trammel, no. Construct the hyperbola as a cone, no. Finding the focal, the normal, and the tangent of an ellipse. So this is the correct answer. Right, number 2. Number 3. Question number 3 refers to the diagram. The diagram above shows the construction of a triangle when giving the hypotenuse and one side. Let me see if any of those see that. When giving the hypotenuse and one side. Let me see, which one says that? Altitude and vertex, hypotenuse and one angle. Well, hypotenuse and one angle or hypotenuse and one side. Well, no. This is hypotenuse and base angle. Yeah. Hypotenuse and one angle. Hypotenuse and one angle. Yeah. It's important to note. So this is correct response. Hypotenuse and one angle. It could be one angle or one side. All right. It's important to know that any triangle that is formed within a semicircle, the angle is always 90 degrees. Yeah. So please note that. Always 90 degrees. Yeah. So please note here. You see, once you join the line from the base of the semicircle. All right. So answer here is that. Next one. Probably I should just give it an answer and not explain too much because we're not gonna have much time. Now, this is in the diagram ABCD is a parallelogram. The triangle ADE is equal in area to half of ABCD. So this is a triangle, and it's important to note that any triangle again that is formed within here, any triangle that is formed within here is half. So look at this. If we were to extend this from here to here, yeah, you would get half of that. If you were to move point B from here and move it to this point, move it to here, it will still be half. Why it is half? Because they share the same base and the same altitude. Altitude is their height. So once a triangle share the same base, and same height, it is half the area of the figure. All right? Any question?
No, sir.
All right, let's move on. So the answer is anyone that says half ABCD, which is that one. Let's move on to this one, number 5. In the construction above, the angle X is 75 degrees. So first, to get that, you first construct. So first, use here as center, we draw first arc. Yeah? Then we use here as center, we scribe one arc, then it would have been another arc around here. Yeah? Then we, well, let's draw the perpendicular first, then a bisect between here, and then a bisect between here. So we would bisect between here and there to get the vertical. Then you'd bisect between, so if from here to here is 60, here to there is 60, you'd here to here will be 30. So you bisect between here to here to get 75. So 60 plus 15 is equal to 75. 60 plus 15 is 75. Again, these are basic geometry that you do from grade 7, etc. So the angle here is 75. Number 6. And this would come under occupation, health and safety. The fire emergency exit door leads from a workshop should open outward, sideways, upward, or inward. Where should it open? So they should open outwards. If you open outwards, just in case of a fire, you can push it out. So this is the building. This is the door. The door should open this way, outward. So in the case of fire, you just run and push instead of pulling this way. You get me?
Yes, sir.
Instead of pulling, it should open outward. All right. In the triangle EF and EF1 in the ratio 3 to 4, the length of EF1 is length of EF1. So the ratio is 3 to 4. So this would be 4. So its ratio is 3 to 4. This is basically maths. So this would be 4 over 7, 4 over 7 by 45. So we have 4 over 7 and we have 3 over 7. So the ratio, so that would work out to, based on, you don't even need to do maths. You realize that this is 60 because it could not be 90 because it's not double, and it is more. So for that we would have them work out it with maths. So 45. So 45 by 4 equal 180 divided by 7. No, they couldn't work away there. 4, they couldn't work away there. So this would basically be 6. So what you do, you then draw a line from here in AutoCAD and you divide this line into 1, 2, 3, 4. Then you join here to there. No. Then you join so it's 3 to 4 would be 7. It should be 3 to 1, 2, 3, 4. So it would be join 3 to that, and then bring this out. Yeah, that's how you do it in drawing. So you join 3 to that end, and then extend this out, draw a line parallel to 4, and that will give you that. So this will work out to about 60 based on length of that. All right. I think I'm explaining too much. Probably I should just give you the answer for them, and then probably at a later time we can, you know. All right. The cone section AA appears as, I think this one is a parabola. This is a parabola. Again, this is something that I might need to cover. It's the parabola. All right. Parabola. Parabola shape something like this. And that's how that would shape. These are things that you probably should have covered from lower school, from grade 10, I mean. All right, let us move on to this. This is equal area. This is a topic that you probably should have covered from grade 10. Probably haven't covered it. This is pretty much how you draw a square equaling a square equaling area to a rectangle. All right. So the procedure here. Let me not go to the procedure now, but by looking at this is a square equaling area. All right. So if from here to here is 40, they want to know the distance for EF. If from here to here is 40, what is this distance? EF. Well, EF is square. This distance is the same as this distance, as all four sides are square. If here is 40, from here to here is 40, from here to here is 40, then the most realistic one would be 55. Yeah? Would be 55. It could not be 35 because 35 is less than that. Could not be 75, so the only realistic one is 55. Practical one. Which of the following length of EF is in the construction? Well, what is the length of EF in, 55, same question. Which of the following construction is illustrated here? This is isometric circle. Isometric circle. Isometric circle, which is C. With isometric circle, we draw the line like that, isometric circle. and we mark or draw a line through the longest diagonal. Find the center for this. Then we join from here to there, here to there. Where here meets, you could draw a line through the center if you want, or you could just mark the center point there. You use here as center, open a compass to this radius, then you draw this arc to pale. Here as center, get the first arc. Here as center, open a compass, here as center, open a compass to that radius, draw that. Here as center, open a compass from here to here, get that. Same thing for here. All right, that could have been that for that. This one, item 31 refers to the following diagram, which shows the orthographic projection of a block. Orthographic projection is when you see here is the top view, the end view, and the front view here. On which of the following plane is the plan? So the plan is the top view, and the plan would be this one right here. This is the top view, which would be this is the top view. This would be the end view. So
one
only, two only, three only.
3 only.
This is three only, yeah, three only. Yeah, three only. For this one, in the diagram, which of the following, which of the labeled type of line indicates a cutting plane line? And a cutting plane line is a line that cuts through a figure. So it would have to be this one. It's a cutting plane line. This is a center line. This is a dimension line. Dimension line, hidden detail line, cutting plane line, and this is a, I is a center line, and 2 is a cutting plane line. So 2 would be the cutting plane line. This one right here, B.
Sir.
Yeah.
It's still about a Mr. number 10 of 55, sir. I don't know. Oh, you get 55.
How?
Yeah.
All right, good. Me like where you talk up. Okay, 55. All right.
Would it be 35,
well,
sir?
huh?
Would it
Alright.
be 35?
All
You're
right.
not gonna be 35.
That less, it way more.
All right. Look at this now. No. If from here to here, this is clear. Here is here, and here is the same dimension, right? If from here to here, this distance here is 40, it means that from here to here is also 40. Here is also 40. You get me? From here to there is also 40.
Yes, sir.
Because it's the same radius. So by virtue of here being 40, these two are pretty much eliminated. Because here to here is much larger. From here to there is much larger than 40, not true? You get me?
Oh, yes, sir. Yes, sir.
So it has to be between these two. And it could not be 75 because this little space right here so could not be 35. Yeah? So the best one is ID, well, the realistic one is 55.
Oh, all right, sir.
You could also use drawing. You could also use TD to work it out, but that would take a little time. All right, let's move on. All right. Which of the following can be found if the major and minor axes are given? All right. Again, this comes back to the previous, second question, or third question. Which of the following can be found? Focal point can be found, the normal can be found, and the tangent can be found. Which of the following can be found if the major and minor axes are given? Once you have major and minor axes, you're speaking about an ellipse. Major axis, minor axis, ellipse. Yeah? Remember we did ellipse in class? Yeah? Ellipse, big circle. Remember that?
Oh, yes, sir.
Yeah. Again, guys, these are on my channel. Go and watch those videos. You see, if you watch those videos, you would be okay with this part of the question, the paper. So this would be the answer for this. Which of the following polygons can be constructed in this circle? Which of the following polygons can be constructed in the circle that has a radius of this 8p, and radius of 8p, that's mean that for 8-sided figure, 6 to p is a 6-sided figure, 4 to p would be a 4-sided figure. An 8-sided figure, which of these is an 8-sided figure?
Octagon.
Octagon. So it would be
Octagon.
a D. It would be a D. Yeah. All right. If the perimeter of a triangle is 120 millimeters and its sides are in the proportion 4, 5, and 3 respectively, then if the perimeter of a triangle equal to 120 millimeters and the sides are in the proportion 4, 5, and 3 respectively, then the length of the side in millimeters are, all right. So for this, let me come out of that. All right. All right, so we will need some maths for this one. So the length is 4, the first one is 4 over 5 plus 4, 9, 10, 11, 12. So that is 12 by 120, by 120. So this is basically 10, 10, 4, 40. So the 4 one is 10, 4, 40. So the 4, so this would be, so this into that 4 by 10, divide this and you get 10, 40. So anyone that has 4, so 40 is one side. That is 5. So this is 10, but this is also 10. 10 by 10, this is if we change to 5, so 10 by 5 is 50. So we don't need to go any further. So 5 over 12 by that. So this is that is 10. 5, 10 is equal to 50. We don't need to go any further. We don't need to go any further, because we have 4, 5 is automatically working. So this is the answer. This is maths. See what I go on?
Yes,
Any question?
sir.
Yes, sir.
So me there.
Yeah, man. Cool. No one
Me
to
there
say.
put me like keep on going and come back.
All right, all right. Now I'm recording. All right, so yeah, all right. Which of the following is used to draw an octagon if the length of one side is given? Octagon has 8 sides, so we can use a 45-degree set square. All right, 45-degree set square. Which of the following is used to draw an octagon if the length of one side is given? All right. Octagon has 8 sides, all right? So you would draw, let me show you how you do it. You would first draw the first side, then you'd use your 45-degree set square, 45-degree set square, and you would draw the other side right here. You draw the 45-degree set square here, and you draw one side, draw this side, then you put the 45-degree set square, 45-degree set square on this side, draw the other side, then you draw this one up, measure your length, use the 45-degree set square again and draw yours, and you automatically get the 8 side for the octagon. So 45-degree set square would be used there. In the diagram above, in order to divide AB in the ratio 4, 5, and 3 by proportional division, it is necessary first to A, divide 7 to that, step off 12 equal parts. The first thing you must do is to step off 12 equal parts. So we add these, again, these come from maths. We have 4, 5, and 3. We add these, 4 and 5 is 9, and this 12. So we step off 12 equal parts, all right? Equal parts. And then we will mark 12 equal parts on this line. 12 equal parts here. So 1, 2, 3, 4, 5, 6, up to 12. And then we'll mark off 4, 1, 2, 3, 4. Then we'll mark 5, 1, 2, 3, 4, 5. Then we'll use our set square to join here and draw a parallel line here and there. And that's how we would always divide this line into a ratio of 4, 5, and 3, right? Let's move on to number 19. Given that one of the angles of a rhombus is 120, which of the following is the value for one of the interior adjacent angles? First thing we need to establish here is the shape of a rhombus. A rhombus is basically a kite. It looks something like this. If this angle is 120, obviously it has to be this angle that is 120. Angle is 120. 120. Remember, all 4 angles must add up to give you 360. So this angle is also 120. This is 120. This is also 120. That would give you a total of 240. 240. And when we subtract 240 from 360, 360 subtract 240. So 360 subtract 240. We're left with how much? How much left? 120, right? Equal 120. When we divide this 120 into 2 to get both angles, divide this by 2, divide that by 2, would end up with 60.
60.
Yeah, equal to 60. So the angle for that would be, and 60 there, would be 60. So
Yes, sir, I see.
There will be 60. Right? All right. Let's move on to another page. What is the value of the angle P in the diagram? Well, we know that angle on a straight line measures 180 degrees, right? So
Yes, sir.
if we add up these and subtract what we have from 180, we should left with how much? What's P? 90 plus 50 is how much? 90 plus 60 is how much? 150.
And 30.
And when we take away 150 from 180, how much you left with?
30.
30. The answer is 30. A quadrilateral with one pair of parallel sides is what is that? Trapezium. A trapezium. Yeah? So